Hello, hi. Welcome to the new video. Here in this particular video, we are going to discuss about Docker Swarm and why it was used and what is the architecture behind it and how to set up a Swarm clusters and what is the services and tasks and what is the deployment we are going to discuss and what are the key features and benefits of Docker Swarm and some real-time practices with comparing to the Kubernetes. Okay, so without further ado, let's enter into the video and have a discussion around it. So first of all, let's start with the basics, like what exactly the Docker Swarm. Basically, a Docker Swarm is a, let me bring up a pen. Yeah, basically a Docker Swarm is a one of the tool that helps us to manage many Docker missions as if they were one. Imagine you have 10 computers, each running a Docker. Without a Docker Swarm, you would have to manually deploy a containers on each mission. That basically takes a lot of time and it allows a lot of messy also. So with the help of Docker Swarm, you can connect those computers into a cluster. Now you can deploy a containers across all of them with a single command. So think of it like a just kind of a non-technical example. Let's say if you are building a house, okay, so obviously let's say if you are considering without Swarm, okay, Docker Swarm, it is like one person does every work, like laying a bricks, wiring, plumbing, and it basically slows down the process and it allows a fragile. Fragile is basically a point of failure. Okay, so if that particular person is not available, then that particular work is stopped. Okay, so that is the case of without a Docker Swarm. Um, in the case of with the Swarm, what it happens was a team of workers will be there, and each of them have a dedicated role to work. And if one worker gets retired or is on leave on that particular day, others can manage and continue that person work also. There will be a coordination and reliability is there and scalability is available in this particular case. Okay, it is just a sorry, it is just a kind of non-technical example. And coming to the what exactly the Docker Swarm solves the problems. So if you see, um, there is no manual involvement, especially the container deployment, and there is no need to restart your containers manually if something fails. Okay, so it will automatically scaling will be there, and no external load balancers is needed. Why? Because there is a built-in load balancing will be available. And coming to the some features regarding the Docker Swarm, if we talk about the features, it provides a load balancing where it will allows the traffic is spread across the containers, and there will be a feature like a self-healing. Let's say if there is a failed containers, so it basically restarted those failed containers automatically. That is the self-healing, and there will be a zero downtime updates. Let's say if services uh, need to be updated, so without any downtime or without any stopping the service, it will be upgraded. And easy scaling also available where we can add more containers or more missions anytime. And there is a service discovery feature also where containers can find each other by the name. And in short, like managers makes a decisions and workers do that particular work. That is basically orchestrate and execute. So managers basically orchestrate the platform and workers basically does the end job. That is basically managers and workers. I mean, I will discuss about managers and workers in the further slide, where exactly we will talk about the swarm architecture. So now let's understand what exactly the architecture, uh, I mean how the Docker swarm is structured behind the scenes. Basically, a swarm cluster has two types of nodes. One is master node and another one is worker node. So in master nodes, these are the like it is it acts like a brain. Okay, master nodes. So it is responsible for deciding which containers uh, run where, and that will basically keep track of the cluster's health and handle the commands like creating service, deleting service, like that. And they use something called raft, basically. Raft conscience, we can say. So it is basically for voting. I mean, it is like a voting system to agree on the decision, and uh, it always use odd numbers for managers, like 3, 5, 7 managers. Why? Because decisions need a majority vote. With the even numbers, you can get a tie also, and the system won't know what to do in that particular case. So that is the reason it follows odd number system. And coming to the worker nodes, here these are the like hands. They can run the assigned containers, and they can report health and status, and they can execute and I mean they can execute the instructions which is received from the manager. And here in the entire scope, managers can run tasks, containers too. So managers are the instructions here, and but in the production, if you see, it's better to keep them focus on a decision making. I mean, it's kind of just a node point. Okay, so managers also can run the actual task in the backend, and for use case in the production environment, better to keep the managers as a decision making use case only. Okay, not for actually executing the job. Okay, why? Because there is a worker nodes, you can use the worker nodes for that particular purpose. And coming to the next thing regarding the setting up a Swarm cluster. So here let's now set up a cluster. Let's deep dive into a step-by-step process. What exactly it involves. Initially, we need to. I mean, the first step was we need to initialize a swarm on your first manager node. We need to run the command that is docker swarm init, and then hyphen hyphen advertise hyphen add r. Okay, and the IP address. So this particular command basically uh, starts the swarm mode and tells the others node where to find this particular manager. And then in the second command we are going to generate a joint tokens. So we need to run this particular command, a docker swarm join token worker and docker swarm join token manager. So basically these commands give you a secure tokens, other missions use them, I mean these particular tokens, to join the clusters. And the third step was joining nodes on a worker mode. So we need to run this particular command to join workers. Uh, a docker swarm join hyphen token, and here the token we need to pass, and then the IP address and the port number. So here in this particular as a command we need to replace the token with the one which is generated earlier in the second step. And then in the third step we need to verify, and in the fourth step we need to verify with the command docker node ls. So this basically shows the all nodes in the cluster, their roles and associated status also. So these are the ports used for cluster management, 2377, for node discovery 7946, and for overlay network we use 4789. So I mean basically overlay network means for containers communication across the missions. And coming to the next steps, let's talk about a task deployment and services. So if you see in Swarm, we don't run containers directly. We are going to create a service. So a service is basically, I mean, we need to know about a service first. Okay. So if you see the what exactly the service concept was, a service is uh, a kind of a um, sorry uh, I mean basically a service defines what exactly need to run. Okay. It says what image need to run, and how many copies, and where to run. This will be uh, I mean said by a service. Okay. And coming to the task is the actual running container. Okay. So this is a slight like difference between service and a task. So service, it says what image to run, how many copies they have, and where exactly need to run. And task means uh, actual running container. And coming to the services, there are two types of services, which is a replicated service and global service. So in replicated service, you specify how many containers to run. Okay. If you see here the three, this is the like number of containers, how many containers need to run. Okay. And this is the full command, docker service create hyphen hyphen replicas, and number of services, and then what is the service name. So this runs the I mean this particular command runs the three nginx containers across the cluster. And coming to the second type of services, which is global services. So here one container runs on every node. Let's say for example, docker service create hyphen hyphen mode global cadvisor. Okay. So basically, which is I mean this particular command is useful for monitoring the tools. Okay, and to manage the services, we use Docker service a scale web is equal to 10, where it will basically scales the services up to 10 containers. Okay, and this is another command where it will list all the services, Docker services ls and Docker services ps space web. Basically it shows where each container is running. And moving to the next slide, which is regarding some key features and benefits. So if you see, I mean, Docker Swarm is, I mean, powerful in these aspects. If you see, high availability, which is basically if a node fail, tasks are moved to a healthy nodes which is available. That is basically high availability, and a self-healing where containers that can crash, I mean that which is crashed or restarted automatically. And automatic failover, basically automatic failover that will manages uh, I mean managers elect a new leader if the like current one goes down. So that is the automatic failover criteria. That is the reason we do have a uh, I mean, in the first slide I show uh, there is a I mean there is a option or else there is a feature that have a capability for voting. Okay, so that feature is useful here in this particular case. Okay, and the next thing was load balancing. Okay, basically load balancing means the incoming traffic is spread across the containers which is available, okay, to take the load. And rolling updates. So the updates, I mean, rolling updates is basically it will updates the services without any downtime. And the another feature was the horizontal scaling. So horizontal scaling means it will add a more nodes to handle a more traffic. Okay, the nodes count will be increased. Horizontal scaling. Vertical scaling, that is different, which increases the configuration of the existing node. Okay, so here the horizontal scaling will be done. That means additional node will be added. And the next benefit was service discovery. So service discovery basically means a containers can find each other by the name. Okay, so the next benefit was overlay networking, which is basically means containers on different machines can talk securely. Okay, so that is the like benefit overlay network. And moving to the next slide, which is regarding some example and some best practices. So let's look up into some real world example of an e-commerce application. We deploy three services here. One is front end, which is running an Nginx service. One is back end, which is running a Node.js service, and the database, which is MySQL service. So these are the commands used. Okay, so here docker service create hyphen hyphen name front end hyphen hyphen replicas 3 hyphen p, which is this particular port, and the service. Okay, so these are the three commands which is created for and coming to the best practices, I mean, these were the real-time example. Let's say we have a three services for your e-commerce service, e-commerce application, we need to use this particular command in the Docker Swarm case, okay, to manage the like existing services and containers, okay. And coming to the some best practices, so here we see use overlay networks. Basically, by using a overlay networks, the services can talk in a secure manner, okay, and keep managers dedicated. That means don't run containers on those particular managers, okay. We need to use workers, okay. So managers uh, need to be dedicated for specific jobs, or else for a decision making, okay. What service need to run in which node, okay. And monitor with the Prometheus. Basically, monitoring with the Prometheus is for metrics and alerts management purpose, and rotate join tokens. So we need to regularly rotate join tokens for security reasons. And coming to the like last point, which is regarding Swarm versus Kubernetes. So we all know like Kubernetes is also used for managing a Docker containers, and Docker Swarm also does the same. So here, I mean, just a small comparison how and where the Docker Swarm and Kubernetes will be helpful and useful. Docker Swarm is which is simpler, and which is great for smaller setups, and Kubernetes is more complex, but it will comes, I mean, basically it will offers more if like futures or controls, we can say. So that is the use case of Swarm, Docker Swarm, and Kubernetes, okay. And Docker Swarm, which is provided by a Docker, and Kubernetes, which is a open source by Google, okay. And yeah, these are the things I wanted to discuss in this particular video, and stay tuned for more videos. Thank you for watching the video.